Chapter 20. Statistics and mathematics are two different fields. However, statistics questions are often asked in assessments with questions that are mathematically in nature rather than statistical. For example, the average weight of 50 prize-winning tomatoes is 236 pounds. What is the combined weight in pounds of 50 tomatoes? Or Joe had 3 test scores, 78, 76, 74. Mary had 72, 82, and 74. How did Joe's mean compare to Mary's mean? Or table 20.01 gives the times each girl has recorded 7 trials of the 100-meter dash this year. Only one girl may compete in the upcoming track meet. Which girl would you select? The first one requires the formula for mean, working backwards through the formula of mathematics thinking, not statistical. The second problem, the questions, is about a conceptual process. The final question is statistical in nature because the situation requires analysis, graphs, or averages. To meaningfully learn and do statistics, students should be involved in the full process from asking and defining questions to interpreting the results, such as 1. Formulate the question, collect the data, analyze the data, and interpret the results. Statistics is about more than making graphs and analyzing data. It includes both asking and answering questions about the world. Students, even younger students, should have the opportunities to generate their own questions, decide on appropriate data to help answer these questions, and determine the method of collecting the data. Students should engage in conversations about well-defined questions. When students formulate the questions, the data they gather becomes more meaningful to them. You can formulate questions about your favorites, TV shows, games, movie, ice cream, video games, etc. Numbers, number of pets or siblings, hours of TV watch, hours of sleeping, bedtime, and measures, height, arm span, area of your foot, long distance jump. 20.1 and activity 20.2 are both great activities to help formulate questions. Here are some examples. How much change do I have in my pocket? What is the typical amount of loose change a person carries in the pocket? What cereal is most healthy? The reason do people use in selecting gum? How long do different kinds of gum keep their flavor? Which store has the best price? Where you buy your shampoo? Questions 1, 3, and 7 are not statistical in nature. Question 3 could be adapted to be statistical, and question 7 is very broad and will need to be more focused on collecting the data. Data collection. In the figure below, it shows kindergarten class deciding to organize their data collection of favorite ice creams. Students may gather by counting events or hands raising, then move to using a single ballot with limited and then unlimited response options. There are 2 different types of collecting data. Categorical data grouped by labels, such as your favorite vacation colors of your class in the school, parking lot. Numerical data, on the other hand, counting things or measuring numeric data ordered or scaled, like number line, and can include fractions and decimals. Statistics generally does not involve gathering data from the whole population and instead uses a representation of a sample. Samples must take into consideration variability. Examples of that, a poll of a favorite TV show will produce different answers from a survey, depending on the age of the person. To help determine if they have identified a representative sample, ask what is the population for the question. Who or what is the subject of your question? Ask students to consider how they will gather data that will include the representation across the population. Random sampling is, in statistics, it increases the validity of the results and therefore gives the more confidence in being able to make inferences about what you're asking the population. You can use printed resources, newspapers, almanacs, sports record books, maps, various government publications, also children's literature such as Goodnight Moon, Green Eggs and Ham, and so on. You can also use web resources. The internet provides a seamlessly list data that is often accessed with just typing in the question or a phrase or just a keyword. You can also look up official Olympic records, the USDA, the data.gov, Google Public Data Explorer, Better World Flux, NCTM Illumination States Data Map, the Central Intelligence Agency, and the U.S. Census Bureau. Attribute materials can be any set of objects that lend themselves to being sorted or classified in different ways. For example, seashells, leaves, and so on. Attributes are always ways that materials can be sorted, such as hair color, height, gender. Each attribute has a number of different values: blonde, brown, black or red, tall or short, male or female. Activity 20.4, what about both? Give students 2 large loops of string in an attribute book or cards or anything that you've made for attributes. Direct them to pull out the red piece inside one of the strings and all the triangles inside the other. Let the students try to resolve the difficulty of what to do with the red triangles. When the notion of overlapping the strings to create a common area in both is clear, make the activity more challenging. You can use the cards, attribute cards below in this activity. You can have students sort based on Venn diagrams. You could have one just shown on the right, red or yellow, happy, and indicates not a triangle. Which one is left? The sad triangle. Activity 20.5. For this activity, try using students instead of shapes as attribute pieces. Decide on the attributes such as wearing blue jeans, stripes on your clothes, or anything. But do not tell your rule to the class. Silently look at one student at a time and move the students from left to right according to the secret rule. After a number of students have been sorted, have the next student come up and ask to predict what he or she belongs in. Before the rule is articulated, continue the activity for a while so that others in the class will have the opportunity to determine the rule.